Today in this lecture I am trying to explain time-independent perturbation theory in the case of degenerate energy level. So far in the last lectures we have discussed the non-degenerate energy level. For non-degenerate energy level, the wave function psi is a unique wave function. It means for a particular wave function we corresponding a single energy eigenvalue. What is the case of degenerate case energy level means if you have say one energy with two or more wave function with the same energy eigenvalue. Such cases we call degenerate energy level. What happened in that the perturbation for a system with a degeneracy. In that case, so far we have discussed non-degenerate case. That technique is not useful for in this case. So we have to general formulate what is the case of degenerate energy. Suppose so far we have discussed a wave function psi n 0 is a wave function, is a unique solution so far. But in the case of non-degenerate case, we suppose we start with this a general expression. So I consider as a twofold degeneracy. I consider a twofold degeneracy. We consider twofold degeneracy. Twofold degeneracy of En0. We consider wave function with a state with energy En0, and the wave function corresponding this one I take as psi n0 and psi n0. So far in the non-degenerate case, if I have an energy, I have a unique wave function. But in this such cases, the degenerate case, if for one energy level I have two states I have. So with the eigenfunction corresponding to the eigenvalue. If suppose in this case En0 is equal to El0, it means both having the same energy. What I am going to take the first step is I take a wave function. If the linear combination of these two states I took as a wave function, and that's also I take a Cn psi n0 plus Cl psi n0. This is my first step. Here Cn and Cl are the coefficient and they are constant. Cn, Cl are constant. And I consider the time-independent perturbation for perturbation theory for the system like this. So this is I took an example twofold degeneracy. We need to find first order correction. First order correction. First order correction. I have a wave function here. I have a wave function. So we have an equation. What was the equation? H prime psi n0 plus h0 psi n1 equal to en1. This was our equation, general equation, plus en0 psi n1. This was our basic equation. I am multiplying this. I consider instead of psi n0, I replace with 5. Replace with 5 first, and equation become h prime psi n0 become Cn psi n0 plus Cl psi l0, and here h0 psi n1 equal to en1 psi n0 become Cn psi n0 plus Cl psi l0. CL0 psi L0 and plus En0 psi n1. This is my first term, and left to multiply with this equation. Left to multiply with this equation by psi n0. Psi n0. What I am going to get? This h prime cn psi n0 cn n0. So this equation becomes cn psi n0 h prime psi n0 plus cl psi n0 h prime psi l0 plus settle this one and this one psi n0 h0 psi n0, and this is left hand side. What about right hand side? Cn En1 psi n0 psi n0, sorry, yes, plus En1 Cl psi n0 psi l0 l0 plus last term En0 psi n0 psi l0. So here final term is psi n1. So it's pretty simple. So you just go through this one, and here we can just simplify this equation. Here many equation. Here h0 is a Hermitian operator. We know h0 is an Hermitian, so we can act in this state also. There is not a changing. So psi n0 h0 psi n1 will give En0 psi n0 psi nl. So this is an arrangement. Finally, what happened here? H prime n acting on n. Here H prime n l, and this term can I write the first term? H prime n. H prime n denominator for this one. H prime n means psi n and psi n minus En1. H prime n En1. What is it? En1 into Cn. What is Cn? Here is Cn is there. Here is Cn is there, and I took both in one side. So here H prime n minus En1. This become 1 and into Cn plus H prime nn. Where is H prime nn? This two H prime nn into Cn equal to 0. Why more H prime nn into Cn? This term psi n0 h0 psi n0 it become I made some mistake. This is psi n1. Okay, psi n1. This becomes 0. This value becomes 0, and finally I already told this becomes psi n equal to 0, and this took a left side, and here psi n0 psi n1 also becomes 0. Remaining term is this one. I took it this. Similarly, I can do the same step left to multiply with by psi l0. Here I took left multiplied with psi n 0. Instead of taking psi n 0, I took psi l 0 multiplied with psi l 0. What happened? I end up with an equation, similar type of equation. It's like this one, ln Cn plus h prime ll minus En 1 into Cl. Okay, so now I have two equation. One equation is here. If I call this is equation number 1, this is 2, this is 3. This is called a non-trivial solution for this equation 2 and 3 exists only for this is a 2 equation. The solution for this 2 and 3 will exist only when the determinant of the coefficient vanishes. Here C and Cl, here C and Cl. I took a determinant of this equation, then it becomes h prime nn minus En1, and here the coefficient is equal to h prime nn, and here h prime ln, this h prime ll minus En1. The determinant is equal to 1 is, then only the solution will exist. This is called circular equation. Circular equation. So okay, so if I took a determinant of this one, it's become h prime nn minus En1 h prime ll minus En1 minus h prime En square is equal to 0. This I can simplify by opening the bracket. It's become h prime nn into h prime ll plus En1 square minus h prime nn En1 minus h prime ll En1 minus h prime nn mod square is equal to 0. And I just rearranging this equation, I can recognize in this form En mod square minus h prime nn plus h prime ll En1 plus h prime nn h prime ll minus h prime nn mod square is equal to 0. Prime mod is equal to 0. This is in this form a square plus bx plus c. This is the c, this is b, and here a. So this form ax square plus bx plus c. And I took the solution for this weekend. So solution is En1 x. X is nothing but minus b plus or minus. We know for this case x is equal to minus b plus or minus root of b square minus 4ac by 2a. In that way, I took this solution for this case and ended with the formula En plus or minus 2 solution I have. It's become h prime nn plus h prime ll of plus or minus of h prime nn minus h prime ll square plus 4 h prime nn mod square root of these two, En plus is one solution, En minus for two solution. So I have a first order correction for energy with a one correction En plus, another correction En minus. So what is the this is of solution equation, and what is the total energy then now? En is equal to En 0, this is the unperturbed energy, plus En plus first order, and En is equal to En 0 plus En minus first order. So this is the two. So actually there is a two type of energy now. You end up with a two type of energy. So the degeneracy is broken here. So the main thing is, before the energy is a degenerate energy level. Now the energies differ with two different values. So it's not all same. Two levels are not same. So it means the degeneracy is broken due to this perturbation. The perturbation is removed the degeneracy in this case. So this is the theory, basic theory of a degenerate energy level. What is happening if suppose if Cn is equal to 0, if Cn is equal to 0 and in that case Cl is equal to 1, then equation 2, the previous equation I erase that one, equation become H prime NL is equal to 0, or equation 3 become H prime LL equal to En1. So this actually should be included in the general result of with the minus sign. So H prime LL is equal to En1 means our the unperturbed energy state. So the same way, and plus sign if En is equal to 1 and Cl is equal to 0, and that energy level is correspond to the plus sign En plus, okay, so it's make E minus 1 is equal to H prime LL is equal to psi L0 H prime psi L0, and E plus correspond to H prime NN is equal to psi N0 H prime psi N0. So this is what we obtained from the non-degenerate case. If Cn is equal to 0 or Cl is equal to 0, this general formalism is back to the non-degenerate case. So the idea is, for the degenerate case, we are treating in a different way. That's the states are not unique to a particular energy. So while doing this problem, what is going to happen? The corrected energy will be differ from the original energy. Initially the energy En0 both are same. So that's why we call it a degeneracy. Here we consider twofold degeneracy. So while taking this, so I will draw a curve here. Suppose this EA and this is lambda. Lambda due to the perturbation. Suppose this is En0 unperturbed energy level. So for the states having same energy level, if the perturbation is applied, the energies are differ with the two values. This is 1 correspond to, suppose this is perturbation is equal to 1. It means that the system is perturbed, and in that case here one energy level become En0 plus En minus, and this is correspond to En and 0 En plus 1. Here in this case, if H prime NN, H prime NN and H prime LL both are same, and if h prime n n and h prime n l are both the same and h prime n l is equal to 0. Where is it is in our equation? I put our equation number 2. Yeah, in our determinant equation h prime nn minus, in this case if h prime nn is equal to h prime nl and h prime nl is equal to 0, then what happens? This en plus is equal to en minus. In that case, if h prime nn is equal to h prime nl and h prime nl is equal to 0, in that case this character term en plus should be and also n. So in that case what happened? In the first order the degeneracy is not removed, we need to look for the second order. In that way we will do the problem on this one. This is a general formulation for the perturbation theorem, time independent perturbation theorem for the degenerate case. What is that? The main point here is that for the perturbation is reason for the removal of degeneracy in this case. Degeneracy can remove due to this perturbation. So we will do the problem on this one in the next lecture. Thank you.